Yeah, so my name's Taylor. Today I just want to give you guys kind of a story of how we started up our search team at Ibotta and some of the learnings that we've had. And then at the end, I'm going to go over some of the interesting work we've done using machine learning and to do query expansion. Yeah, so I haven't been doing search very long. I basically been doing it full time for about a year now. Last year, I had just finished reading Doug and John's book, and I was like, hey, so do these guys blog or anything? I was like, oh, there's a conference. So I came out to the conference last year and learned a lot. And so I took that back, and we started applying stuff to Ibotta's search feature. So real quick for reference, Ibotta is this online rewards platform. We're kind of attacking the coupon industry. So in the app, you can basically find rebates for common things you might go buy. Right now, it's mostly grocery items. We're kind of working into the online space, so that's going to make my job a lot harder. So for the purpose of the talk, I'm going to be talking about these rebates as offers. That's what we call them internally. And so the offers are interesting. We have a bit of a unique search challenge in that our clients treat our platform almost like an ad platform where they'll give us a budget and we'll run some offer on, say, like Kellogg's cereal for 3-4 weeks or something like that, and then it's out of the app. So for a user, they get to experience this terrible experience where you go and search for something, you find it 1 week, and then the next week you go to do your groceries and it's gone. So we were running into this, like one of our big problems that management kept complaining about was like we have these dead end searches, and like Renee was saying, that's a very bad experience with your users. And then we also, because of these dead-end searches, we were also looking at like, okay, can we turn this into like a bit of a recommendations platform if we are missing on a search? So yeah, we spun up our team last March, basically. Shortly after that, we were spinning people up to learning Elasticsearch, and then. Early in the summer, we started building out Taxonomy. We eventually moved that into doing word embeddings, and then our more recent work was we've been working on doing actual query expansion. So this was what we basically picked up. Early on in the app, there wasn't a lot of effort put into search, so you get they were just like, hey, I guess we need a search feature, so they just kind of threw something together. And this was a pretty common experience if you looked for very specific terms. You'd also run into like really odd results as well. It was basically just thrown together with like a quick Elasticsearch query that's just doing matching out some tokens. So yeah, there's you can see like it did bring back some kind bars, but it's also matching on like these n-grams of kind and Kindle and Kinder Joy. So we wanted to fix that. Yeah, it was an okay search experience, but we were looking at like how can we improve this? How can we get related content? If you look up kind bars, we know that there's granola bars and other sorts of things in those categories as well that we could be returning instead of things like a Kindle. So we were given this directive, right? And the product managers were basically just like, okay, make search better. This is right? It's like Amazon and Google have made this problem really hard for us, right? They've basically perfected search, and so people see that, and then they're like, okay, go engineer, make search in our like little app with 1 million users, like make that work well, and it's an easy thing to identify, like yes, this works, right? It's hard to identify like how do you actually make a good search experience. So what we started with was starting to analyze how our users search. It's easy to just go out and be like, okay, well, how do I want search to work? But luckily we had the tracking data, and we went through and found, we analyzed to find like our top search terms. And a lot of these are what you would expect for a grocery rebates app, right? Like your weekly staples, milk, bread, eggs, cereal, stuff like that. People were also searching for their favorite brands. And then some people would also search for categories of things. So maybe they're at the grocery store and they're in the dairy aisle and want to see what's available. The other thing we were taking note of here is that there's also a lot of opportunity for synonyms. You see things like, okay, someone searches for Coke, and that they might want Coca-Cola, but they also might just want a soda in general. So it's hard to make that distinction, and that's an opportunity for us to sort of expand our query a bit. So the first thing we started looking at, we were doing some reading. We were like, okay, well, we need a taxonomy. The app had we already had categories indexed on our documents, but they were categories that were made specifically for navigational purposes in the app. So some of them made sense, and then some of them were kind of like, concatenating a bunch of things that weren't very common, or in general, the biggest thing we didn't like about it was that we don't have any control over it, because we don't, as the search team, we don't have like the purview to be like, we're going to change navigation in this app. So we started asking around with the machine learning engineers and like, hey, can y'all help us make a taxonomy? Turns out they already had one, so that was really easy. And they were using that for other recommendations throughout the app, and so we were able to just go and ingest it. So this allowed us to do things like, okay, now we have maybe ballpark beef franks. That's, most people colloquially call that a hot dog, but if you're just trying to match on tokens, you're not actually going to find that in your search experience. So now with a taxonomy, we can have this hierarchical categorization and have that. And so then if a user is just looking for like, hey, I'm going to a barbecue, I need like meat or something like that, you can match. It also allows us to take brand names and turn them into like descriptions of what the actual product is. So this was our ML teams had already had this Qubel Spark job that was generating these, and it was just dumping it to Amazon S3. So we just wrote a job that would go and pick them up off of S3 every day and index it onto our documents. So yeah, this was a great win for us. It gave us this fine-grained categorization, gave us more targets onto our documents that we could users could possibly land on, and it gave us control of the categorization and more control over the data that was on our documents. Ultimately, we didn't actually see a large spike in our metrics, like our click-through rate and whatnot. So we kept going. We just kept trying to think of new things. So then we were like, okay, can we actually use synonyms, right? And we were thinking about that and like, okay, can we like, a user's like maybe thinking about hot dogs. So like easy one, they're looking for a hot dog, but they might also look for a red hot depending on where they are. They might look for sausages, which a hot dog's technically a sausage. They might be on their way to a barbecue, so they might be looking for hamburgers, buns, ketchup. So we're starting to get into this idea of like, can we start like making some recommendations along with our search? So we did some reading, and we found out about this thing called word embeddings. There's a lot of information about word embeddings online. It's pretty hot in the industry. So real quick, I know Renee just went over this on his last talk, but if you were there, but so word embedding is basically taking a word and turning it into a vector representation of its meaning. So in this case, you can take something like, we have like a vector here that represents man and a vector that represents king. And you can actually do math and subtract king minus man, and you get this vector that is some sort of representation of authority. You can then take that, add to woman, and get queen. I just lasered onto my monitor. That's cool. So yeah, the way you generate these is we use the method called skipgram. So you can take a corpus and basically go through, in this case, where n is 2, You take every target word and you can create training pairs of like, basically, here's all the words that occur within two indices of each other. And then you can train a model that will take this and generate a vector where a simple way to explain it is it's basically the probability that any word would occur near any other word where like each word is like x of n. This allows you to take your words and graph them onto an n-dimensional space. And then we took a k-means clustering algorithm and you can generate these clusters. You assign arbitrary labels to each cluster. Since it's unsupervised, we don't actually, like the computer doesn't know what the cluster is. It just knows these things are similar to each other. And then you can take that and put it into Elasticsearch or Solr and with the Synonyms feature, and you basically map every word that you trained to some cluster label. And so what this does behind the scenes, if you're not familiar, is that it actually indexes these labels. So if a user searches for sandwich, it'll bring up BLT and burger. So we use the word2vec algorithm and k-means. I went over all this. So this is actually a pretty easy feature for us to implement just as beginners. Like there's lots of tutorials online. There's lots of libraries available that will just do this for you. It's just kind of a problem of engineering and implementing it. It wasn't, ultimately it kind of caused some problems, which I'll show you some funny examples, but the unsupervised nature means that you can end up with things getting associated to each other that aren't actually associated. It just happens that like the probability of the words ends up making them seem associated. It also doesn't handle like any arbitrary input from a user. And ultimately, it expanded our recall too much on our searches, which we solved our no dead ends problem, but not in a good way. So here's a good example. So in this case, it understands that jerky is some sort of meat. It also understands that it's like related to beef. So we get exact matches on the jerky token for our first two results, and then we get some related content, which ultimately, if you're looking for jerky, you're probably also okay with country anchor meat bars. So, but yeah, it also caused some really weird results, which we got lots of feedback from. When search isn't working well, people let you know. So in this case, we have natural, so we're getting like, these like organic things, some coconut water and yogurt, and then we have an HP Pavilion laptop down here, and I can't tell you why that shows up, or that it's like a really weird conversation to have with a product manager when they're like, what's going on here? And you're like, I don't know. Like, I'm the one that engineered it. I'm supposed to be able to explain that. So on to the next attempt. So yeah, so what if we could like take a user's search term, right? The user's trying to tell us what they're thinking of, right? They're just kind of using whatever term comes up in their head. They're possibly trying to think of what will match onto your content if they're a little more savvy. So we started doing some reading on this idea of query expansion, right? If you're not familiar, query expansion is the idea of manipulating your query with outside information before you actually go and query against your search index. So this can be any number of things. It can be simple things like doing spell corrections. It can be natural language processing and tagging, and then like weighting based on what parts of speech are being used. Or you can do things with machine learning where you can do like entity detection, like is this a known thing in our system, or is this, in our case, what we ended up doing is category prediction. The theory that we had behind this is that many of our users are using the app while they're in the store grocery shopping. So if they're searching for something that's directly in front of them and we can guess the category, we can give them recommendations and similar products that are in the aisle nearby and save them time walking around. So we ended up implementing this as a SageMaker microservice. So SageMaker is a AWS service that allows you to train a model, and then it'll basically spin that up as a little microservice with a REST interface, and just make predictions for you. We use the built-in blazing text algorithm they have, which is basically a parallelized word-to-vec algorithm. And then this time we trained it with a supervised model that we used labels that came from that taxonomy that we had generated earlier. So this way, it's going to make a prediction that aligns with a taxonomy that's already tagged onto our documents. Yeah, so in this case, what we can do is we can take an arbitrary word and we vectorize it in real time. And then, so in this case, we put hot dog. Today, hot dog is a sandwich. Sorry if anybody is passionate about that. And then it'll return a prediction for us saying that, like, I think this is this category, and it'll give us a confidence score. So then we take that and we inject it into our query as a boost. We actually did on our most specific prediction, we actually made it an additive part of the query, and then if it predicts, like, yes, this is a hot dog, it'll actually, like, pull that, like, things that we know are hot dogs. Whereas if it's just like, hey, I think this is meat, it'll just boost things that it finds already in the query that are meat. So this gave us some pretty cool results. We have this live in production right now. So it can understand the difference between, for instance, milk chocolate and chocolate milk. If you were taking these queries just at their face without, like, obviously without phrase matching, if you just try to match these tokens, you would actually get the same results overall. You might also get, like, weird stuff like chocolate showing up when you look for chocolate milk. It also can understand brand names and like this. So it takes Apple Jacks. You get an exact match for Apple Jacks, but then it understands that, yes, you're looking for cereal, so let me boost other cereals. And it also helps, again, like, helps with suggesting competitors. Like, we don't have Tide in our app, or we didn't at the time that I searched for this, but we have Clorox products, and we also understand, like, Tide's a cleaning product, so let's put that in there. It also handles weird stuff like Scrapple. It understands that that's pork, so.
Scrapple's not weird.
But yeah, so we were super happy with that. So this is our architecture. So basically, we have this content service that handles all content requests for our phone app, and then it'll send that term off to SageMaker, gets category prediction back, and builds out an expanded query. Yeah, so that's basically what we've been up to up until now. We have some of the continued work we're doing. So in the process of building out that machine learning prediction framework, we kept it generalized enough that our machine learning teams can both iterate on the existing models that we have and keep playing with some new ones. Since it can just spin up a new microservice, we can quickly add new types of predictions to our query expansion. We've also been looking at, can we expand our query based on what we know about a user? Right? If we have a user's search history, we might know that they tend to look for these certain types of things. So we can use that to boost. We also found during our when we were analyzing our search results, we actually found a good chunk that were questions, which is kind of an interesting aspect of search where like when you put a search bar at the top of an app, users will actually, like if they get frustrated with an aspect of your app, they'll start asking your search questions. So we've been looking at like, can we start analyzing and like, can we do some natural language processing to figure out what they're asking and maybe like link them to like an FAQ page or something like that. Yeah, so if you're new to search and you're like kind of like wondering where to start out, first thing I'd recommend is like get tracking in place right away. If you don't know what your users are searching for and what your click-through rates are and your abandonment rates, you're not going to be able to do much as far as like measuring how good your improvements are or how bad they are. You also you need to understand how your users are using your app. So whether that's looking at tracking data or interviewing users, just working on hunches isn't going to help you. Yeah, and then I would just recommend keeping it simple for as long as possible. Don't try to, like some of our early work that I didn't talk about is like we just read every feature in Elasticsearch and started trying to apply it, and we ended up with this huge query that was super complicated, and it sucked. So like, just incrementally add features on and measure them as you go. Yeah, thanks for your time.
Well, we got plenty of time for questions. Thanks, Taylor. Questions over there.
Hi there. Hi. So I would say in our organization, we've been going back and forth on the actual utility of a taxonomy. We find that our users don't use it navigationally very often. And so I was curious if there was a taxonomy that kind of already was developed and wasn't front-end user-facing, kind of why did your data scientists already have that developed, and how are they using it?
Yeah, so they were using it for other recommendation systems in the app. So we have like things like a home screen where we just, here's recommended for you based on like behavior we've seen in the app. So I think they were using that to be like, hey, they were using it as features in other machine learning algorithms. So like, hey, this user bought these things, and then it's like associating them to like maybe they want other things in that same sort of category.
Other questions? Anyone?
Curious where you got the labels for the classification and how long it took to develop those?
I'm not entirely sure. That was our machine learning team, but I think it was. I think they used. So we have. I do know we have product data on the back end. So we have this offer that's like a rebate, and then it might cover like many products. So we have this fairly robust like products database that have descriptions, and I think they use some machine learning techniques to cover like category information that we're missing.
One thing I'll say is that in about a year time, was it about a year and a half? That's
Yeah.
pretty impressive work.
Thanks.
Another question over there?
I'm curious what kind of data sets you have if you were able to, so you're using Elasticsearch. Do you have enough data to do more like this type of queries in order to draw some of those similar products together? Like, are your data described enough to provide that level of detail, or is it really just the coupons themselves?
Yeah, we do. So we do have you're saying like, can we get like similar products? Yeah, we do have that information, and we're kind of working on that. The offers themselves can be tricky because their text is often like it's some description of like a couple of products it might cover. But yeah, we do have information about like what products are similar, and we can work. Yeah, sorry.
I'm curious, what do one of those descriptions look like? Like talking one paragraph, 2 sentences, and like is that provided by the supplier, the product, supplier itself?
I don't know what the shape of the data is like. I don't look at it a lot, but we get it from a number of locations. So clients will often, they'll give us information about a new product that they're trying to promote. We also use third-party aggregators that'll give us like a lot of information about products across many retailers.
Cool, thanks.
Yeah.
So, first of all, thank you for your talk. So you follow a similar path to what Renee showed before. So you started from words embeddings and the k-means. And then when you talked about the latest supervised classifier, you didn't mention which kind of model you trained. So where you actually, your team was using, again, like words embeddings plus neural network to model the classifier?
Yeah, so it was, where was it? We use this blazing text algorithm. It's basically word embeddings, but it takes labels, I guess. So yeah, I guess the way our team works, we have machine learning engineers that come up with these models, and then so I don't necessarily know a lot about machine learning, and like I'm basically stitching that together and applying it to Elasticsearch, and we're trying to keep the models general in case other needs arise in the business that we could also use them for.
Okay, thank you.
Yeah.
What methods and metrics did you use to evaluate the different approaches?
Yeah, so we're using click-through rate, and we also, ideally we'd want we have this idea of like our redemption of like one of these offers. It's tricky because we don't know. A user can activate an offer and then wait till the weekend to go and actually make their trip, and the tracking data can be tricky to stitch together. So for the most part, we're using click-through rate, or we also track abandonment rate as like a negative metric. Yeah.
I have a question. So I was fascinated by your synonyms generation technique, where you were word to vec terms and then basically clustering. But you had some issues as recall or some sort of weird behavior, right? Mm-hmm. Did you keep that technique, or did you replace it with the category?
At this point, we replaced it. We're going to revisit it. One of the things we can do is pre-cluster things that we know are similar. I think as a first pass, we kind of just took all the product data that we had and threw the algorithm at it, and it was weird. You'd get you'd get CDs associated to cereal or something through. And it wasn't really obvious what how it was doing that. So we can, it's definitely on our roadmap to revisit that and try it again. But yeah.
So you said this is in production already,
Mm-hmm.
and has it been there long enough that you've been able to measure the things like click-through rate and abandonment rate, and have they improved?
Yeah, we were. What was it? We went from 15% click-through rate on all of our searches to 25% when we released that. Obviously, we want to prove that it's not a great threshold, I guess, but yeah.
Anything else? No, we got a few more minutes.
Do you know do you know what store the user is in? Or I saw Walmart at the top of one of your pages. Is it are you already categorized to a particular store so that you don't, if someone's in the grocery store, you don't recommend something from Best Buy or something like that?
Yeah, yeah, that's a feature across the whole app. They've been like A/B testing it. Some people find it kind of creepy, 'cause like, but yeah, we have done that because yeah, it's weird if you're in Walmart and searching. We don't want to like, hey, drive down like 10 miles down the street to go to Target or something, right? So yeah, that we have like filtering and other things in place as well. So yeah. If you're in Walmart, it'll show you Walmart offers.
So you actually know where the user is physically?
Mm-hmm.
Oh, that's why it's creepy.
Yeah.
To sort of piggyback on that point, I think a lot of us think a lot about what is the threshold of creepy in terms of searching and results and tagging, all of those things. What sort of conversations have you guys had about that in terms of how much is too much, especially when it comes to location for you guys? I don't know, I'm just curious.
Yeah. Yeah, we've talked about that. Like we're very concerned about PII. At least the engineers are, yeah, because we have the ability to like give recommendations based on like the part of the country you're in, or you know, even yeah, like sorry, lost my train of thought. Yeah, we're trying not to like be invasive with it, right? The app is like pretty. It tries to make a lot of recommendations, and we don't want to like overstep that. You hear like you hear about like the grocery store, like with your card, they can make predictions and like tell if you're like going through some sort of like life trauma or something, and we don't want to like get to that point, but yeah.
Thank you, Taylor. Another question?
Oh.
Yep, we got time.
Just wondering, for the taxonomy, was that like manually created, or if you have any insight there?
Oh, it was generated with machine learning.
Last question, anybody? All right, then. Thank you so much, Taylor.
All right.
A round of applause.
Thank you.